In Lesson 10.4, you will use inscribed angles and polygons. You will use inscribed angles of circles. So let's first go through the warm-ups. The measure of the interior angles of a quadrilateral, 80, 100, 55, and 5x. So we know that since it's a quadrilateral, they add up to 360 degrees. 80 plus 100 plus 55 is 235 plus 5x equals 360. I might have just said 180. It is 7:30 on a Sunday morning. It's 360. So 360 minus 235 is 125. So if 5x equals 125, 125 divided by 5, x equals 25. Two supplementary angles have measures of 6x and 12x. Find the measure of each angle. Well, they're supplementary, so 12x plus 6x equals 180. So 12 plus 16 is 18. 18x equals 180. X would then equal 10. So this is 60 degrees. And this one is 120 degrees. And 60 plus 120 does add up to 180. Now we're going to solve these equations. Rather than distributing this by half, I'm going to multiply both sides by 2, which means 6x equals 4x plus 12. Subtract 4x from both sides, I get 2x equals 12, so x equals 6. Winner, winner, chicken dinner. And on this one, multiply both sides by 2, so 160 equals 360 minus 2x. I'm going to subtract 360 from this side. And yes, I get negative 200 equals negative 2x, but I divide by a negative and I get back to positive land. X equals 100. Woohoo! An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. The arc that lies in the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc of the angle. Measure of an inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of the intercepted arc. This works if center C is on a side of the inscribed angle, center C is inside the inscribed angle, or center 3 is outside the inscribed angle. This is different than what we've done previously because now the angle sits on the circle. In the prior lesson, that was where we had an angle that used the center of the circle as its vertex. These sit on the outside. So that's how this lesson is different than the prior lesson. So the measure of angle T, this is angle T, is going to be 1/2 of this opposite arc, or this intercepted arc. See, using the vocabulary words from the prior lesson. So 1/2 of 48 is 24. Okay? And for B, measure of QR. You want to find this, let me highlight it so you can see what we're finding. We're finding QR, but obviously we don't have an arc there to deal, inscribed arc to deal with, because this line here is a chord, not an angle. So we can do TQ, which we've all, okay, TQ This is 50, so twice TQ, this part here, would be 100. Because this whole thing is a semicircle, 180 minus 100 would leave that to be 80. So sometimes you have to look at solving a bigger problem to backtrack into solve the simpler problem. Find RS and STR. And then also, what do you notice about STR and RUS? First of all, there's a lot of writing down here, so I'm just going to go through this. RS is going to equal 62 degrees because that's twice this measure. STR is going to be 360 minus 62. I should be able to do this in my head. That's 298 degrees for STR for the arc. I don't know what symbol I did up here. This is really why I probably should not be recording until my first cup of coffee sets it. Okay? STR arc and SRUS arc are the same. Now they are asking though about the angle measures. So they want angle, which is different than the arc. STR actually intercepts the same arc. So angle STR, okay, intercepts the same arc as SRUS. So if this must mean that that's 62 degrees, that this here must be 31. I don't know why I'm writing percent signs. I really have some issues this morning. 31 degrees. Okay, I did a little bit more. I also reviewed the arc measures to show you how you could find the larger arc here, the length of the. So example 2 suggests to us what we're going to learn is our next theorem, which is theorem 10.8. If two inscribed angles of a circle intercept the same arc, then the angles are congruent, meaning ACB intercepts arc AB, and ADB intercepts arc AB. So ADB and ACB are congruent. We're going to use this in a standardized test practice. Name the two pairs of congruent angles in the figure. So let's look at this. JKM and KJL. Those do not intercept the same arc. So it's not those. Okay? JLM intercepts that arc. And KJL, those are not the same. Yes, I know you can see the answer below, but I'm going through how we do this. JKM intercepts that arc. JLM, so these intercept the same arc. Let's see if the other pair intercepts the same arc. KJL intercepts arc KL, and KML intercepts the same arc KL. So it is C. And the guided practice for all of these examples. Okay, find the measure of the red arc or angle. So if this is 90, this is 1/2 of 90, so it's 45. Next problem. This is 38. 38 times 2 is 76. The measure of minor arc TV is 76. And for this one, find the measure of the red arc or angle. So if this is 72, it's going to intercept ZW. They want us to find the measure of this angle. Since this angle intercepts the same arc, it's congruent. So it is also 72 degrees. Now, if they had asked us, they didn't, but if they'd asked us to find this arc, ZW, 72 times 2 is polygon, is an inscribed polygon if all of its vertices lie on a circle. The circle contains the vertices is a circumscribed circle. So these red circles are circumscribed. This has an inscribed triangle. This has an inscribed quadrilateral. Theorem 10.9. If a right triangle is inscribed in a circle, then the hypotenuse, that's the hypotenuse, is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter of a circle, then you know that the triangle is a right triangle. And the angle opposite the diameter is a right angle. Your camera has a 90-degree field of vision and you want to photograph the front of a statue. You move to a spot where the statue is the only thing captured in your picture as shown. You want to change your position. Where else can you stand so that the statue is perfectly framed this way? So this must be the diameter of the circle. Okay? So if we could create a circle, this is a point on the circle, okay? You could stand at other points on the circle that measured in your diameters. You could stand like there. Let me go back to the highlighter because I like that thick line. You could stand over here. The point is that you could stand at other points if you made a circle. So here's how they go. If you know that that is a right triangle is inscribed in the circle. When the hypotenuse of the triangle is the diameter of the circle. So draw the circle that has the front of the statue as a diameter. The statue fits perfectly within your camera's 90-degree field of vision from any point on the semicircle. And we'll go over in class how you could actually construct it. But basically, in order to construct this, you would first have to find the midpoint of this circle. And you could do that by setting your compass here, making your arcs, drawing a line. Then you would find the center of your circle. You then set the point of your compass here, the pencil outside here, and draw the circle around. What if, an example 4, explain how to find locations if you want to find the front and left side of the statue in your circle. Okay, once again, you would have to stand. I'll just read what they have rather than going through it and then reading it. Make the diameter of your circle the diagonal of the rectangular base. So you would stand over to the side, set up your camera so that it's framed, make that the diameter, and you could figure. I'm going to go through this fairly quickly here. 82 plus x equals 180. So x is going to equal 98. 68 plus y equals 180. So y is going to equal 180 minus 68 is 112. So x is 98, y equals 112. X, is that the same problems? Oh, yeah, that was the same problem, sorry. Now, these get a little bit more complicated. Well, this one isn't bad. 10x plus 8x equals 180. That's 18x equals 180. So x equals 10. Over here, c plus 2c minus 6 equals 180. That's 3c, combining like terms, adding 6 to both sides, equals 186. C equals 186 divided by 3 is 62. So C equals 62 and X equals 10. Homework quiz. If the intercepted arc is 76, 1/2 of that is 38. 2 times 28 is 56. So on this one, we're finding the measure of the arc. You can see that of the angle, you can see they intercept the same minor arc. Or really any arc for that matter, but in this case it's a minor arc. So X is congruent to here. So it is 44 degrees. So opposite have to be supplementary. 72 plus 2x equals 180. Subtract 72 from both sides. So 180, 108, 108 divided by 2, x equals 54. And for y, and 100 plus 4y equals 180. Subtract 100 from both sides. 4y equals 100. So y equals 20. And last problem, I think, 21x plus 15x equals 180. I'm not even going to write this out. I'm just going to 21 plus 15. So 36x, ignore that, equals 180. 180 divided by 36 is 5. And 9.5 plus 8.5y equals 18. Y equals 180. So y equals 10. And here are the pages that your homework comes from.